Okay, we're back and we're still talking about numerical calculation of derivatives. And I want to show you one more thing you can do with the graphing calculator. And here's our example. F of x is x cubed minus 4x squared plus 2x plus 3. And we're told to graph f of x and f prime. We want to graph the derivative function. This is the function, the derivative function, that has a value at any point that is equal to the slope of the original function. Now let's graph this function. First of all, I've put it in here. Here's the calculator. I've typed it in. X cubed minus 4x squared plus 2x plus 3. And I've set my window to go from x is negative 5 to 5, and the y values go from negative 5 to 5. And we'll hit graph, and it will plot it there. That's a nice cubic curve. And you can look at this and see what you think the derivative ought to look like. Look at the peak there near x equals 0, just to the right of x equals 0. It looks like it's maybe around x equals 0.2 or something like that. That's where the slope changes from being positive to negative. So that's where the value of the derivative function will hit 0. The slope right there is 0, so the derivative will go from positive to negative at that point. Let me just sketch this real quick so I can point to things and talk about them. Okay, so this function looks something like this. Let me try again. Okay, something like that. And just to the right of 0, the function is flat right there. So the slope is 0, so we would expect the derivative at that x value to have a value of 0. And then right here again, looks like it's at about 2.4 or something. The slope of the function is 0, so the derivative would have a value of 0. And over here on the left part, the slope is positive over here, but it's getting less and less as we get close to this peak right here. So the value of the derivative is positive and getting less and less. And so doing something like this. And then in this region here, the slope gets more and more negative, reaches some maximum negative value, and then the slope gets less and less negative. Remember, we're thinking about the slope of this curve through here. It becomes negative, gets more and more negative, and then it gets less and less negative. So the value of the derivative between these 2 points will get more and more negative, reach some value that is the most negative, and then get less and less negative. So it's going to do something like this. And then the slope here gets steeper and steeper as we go further to the right. So we would expect our derivative function to look something like what I've sketched there in red. Now here's how we can make the calculator do this. Watch this. y1 is the function. I'm going to come down here, and in y2 I'm going to put the derivative. And I'll hit the math key again and hit math and option 8, just punch 8. That's inderiv. So we're going to tell it to calculate the value of the derivative of which function? We'll say function y1. So hit the vars key here, vars, and then hit the right arrow to go over to yvars, and hit 1 for function and 1 for y1. So the derivative of y1, comma, when x is equal to x, close parentheses. And what that means, it's going to calculate the numerical derivative when the variable x is equal to whatever value x has as it iterates across the screen from left to right, doing the calculation. So when we graph this, it's going to plot this curve, and then it's going to calculate the derivative at each point using inderiv and plot all of those points. So I hit graph, and here it goes. And notice that it's taking a little while because it's having to do that symmetric difference quotient at each point and compute a value in there, and it plots something somewhat like what I drew in red there on the screen. And so that's it, the numerically calculated derivative, and we've had it graph it. There's a lot of calculation going on behind the scenes there, but the calculator doesn't mind. That's the great thing about computers, is they don't mind doing millions or billions of calculations in a row. They never complain, they never get tired, and they get them all right. I'll punch the function back up so you can see the syntax again. Type in the function for y1, and then in y2 you tell it compute the numerical derivative of function y1 when x is equal to x. And so when you graph it, It graphs y1 going left to right across the screen, and then it graphs y2 going left to right across the screen. And so the x value changes. In this case, it starts at -5 and it goes all the way over to the right to +5. And each step along the way, the x has a certain value, and it calculates the derivative when x equals that value. That's the second x in our n-deriv function there, the value as it moves across the screen.